Okay, so quickly, I have n minus 1 factorial. This is going to be my y. This x is y plus 1, so I have n minus y plus 1. This is just y factorial. This is p to power what? Y plus 1, right? This is 1 minus p to power n minus x is what? Y plus 1. So let's open this bracket and see. Y is equal to 0 to n minus 1. This is n minus 1 minus y. So we can say this is simply n minus 1 minus y. So like this, factorial. This is y factorial. This is n minus 1 factorial. Are you with me? So this is p, Charlie, this is p to power y times p, so that one can escape. Y is the variable, the iteration, the indexing and notation that we use here. Okay, so anything that doesn't have y can leave. And x is a random variable, which is now y anyway. So we have 1 minus p to power n minus 1 also minus y. Mr. Cheng, I need your attention here. So, does this look like something to you? N minus 1. So again, np comes out. Summation y is equal to 0 to n minus 1. N minus 1, yes? Combination y. Confirm please if you understand, guys. This is n minus 1 combination y. That's the whole idea. Okay? This factorial, this minus y factorial, that is n minus 1 combination y. And this is p raised to power y, and this is 1 minus p raised to power n minus 1 minus y. Compare that to this. To this. Whatever you have here must be on the first and must be n minus the same thing on the second. Do we have a pattern like that? So this is more or less what? The binomial expansion of something. What is that? NP, what is the whole of this? According to binomial expansion, binomial theorem, a plus b to power n is equal to what? Together, quickly.
It's
Summation n equals 0 to, no, r. We always use r, right? R equals 0 to n of n combination r, a raised to power r, we can say r first, then b raised to power n minus r, something like that. So do you compare? So your n is now n minus 1, your r is y. Okay? So we don't, of course, y is not here. So it's going to be the addition of which two? These two. Everything raised to power what? N minus 1. So it's more or less addition of p and 1 minus p, everything raised to power n minus 1. Do you agree? Do you agree? So I can say using a plus b to power n is equal to summation r equals 0 to n combination r, a raised to power r, b raised to power n minus r. Or a raised to power n minus r, b raised to power r. It's the same thing. Do you understand? So, what is the bracket? What's the bracket here? 1. And 1 raised to power anything is what?
1.
So you are left with what? NP. So that's why your mean is just n times, and it makes sense. Okay? It makes sense to think like that. Quickly, we have like 6-7 minutes. So for the variance, we need expectation of x squared. So we'll use the transformation of variable as well. Then we already have a result here. We'll probably need that somewhere as well. Let's see. So similarly, so expectation of x squared, you know, you can do expectation of x squared minus pn of x all squared, right? So expectation of x squared is going to be the summation of x squared times probability. Okay? So in this case, it is the summation of x squared, then n combination what? X, right? P raised to power x, 1 minus p raised to power n minus x. Your x goes from 1 to n. Again, if you apply 0, when x is equal to 0, everything becomes 0, so you have your x from 1 to n, which means there are n of them now instead of n minus n plus 1 of them. So this will remain x squared, n factorial, n minus x factorial, and this is still p to power x, I keep writing q, n minus x. Okay? So now, one of these x can be removed here. So let's do that. So if we do that, you have summation x is equal to 1 to n. So is it okay for me to write this straight away? N minus x. No, there will be one x left, right? Okay. Put it here. Like this. And this will be x minus 1 factorial, p to power x, 1 minus p, n minus x. Is it okay to write this? Talk to me, please. Yes, okay. So let's, where? At the top. And here. Okay, thanks. So again, let's do the transformation. N will be released. So n can escape. X is equal to 1 to n. There's a reason I'm putting this x here. N minus 1 factorial. You might be wondering, why can't we take n minus 1 out? It still has a purpose. Okay? It still has a purpose in life. So it can't go yet. P to power x, 1 minus p, n minus x. So if we let x minus 1 to be y again, then our x is equal to y plus 1. So we change this to y plus 1. This will be y is equal to 0. And this will be n minus 1. Every other thing we change, and you will notice we can split this into 2. So everything becomes sigma y is equal to 0 to n minus 1. This is y plus 1. Okay? You have n minus x. Feel free to move to this side if you cannot see. This is n minus 1 factorial. This is p to power x, 1 minus p to power n minus x. Agree? So,
Can we substitute the x?
oh, I'm so sorry. So it should be what? N minus y plus 1. Yes?
Y, yeah.
And this is
Y plus
y factorial.
Yes.
My bad.
And then
So x is what? Y plus 1 again. 1 minus p to power n minus y plus 1. Like that. Thank you. What? There's an n at the back. So quickly, what do we notice? We can split this into 2. Open the bracket. So we have 2 sigmas. N summation y from 0 to n minus 1. Then we have y. Can you see this? N minus 1 factorial. This is n minus 1 minus y factorial. This is y factorial, right? Then this is p to power, I split it immediately, okay, just to save time. 1 minus p to power n minus 1 minus y again. Then with the same thing, everything again times 1. You still have your n here. Talk to me, do you understand?
Yes.
So this is y is equal to 0 to n minus 1. Who is that out there? Okay. So this is n minus 1 minus y Yes? Please tell me if I've made any mistake yet. Y factorial at the top, n minus 1 factorial. Again, p to power y, p, 1 minus p, n minus 1 minus y. Yes? So in each case, p can be released, and let's see what happens. So when p comes out of there, you have np, you have summation. Again, this is a y, and this is, so this kind of look like something. Is it? np, okay, let me write that out. Because here, we can divide 1, right? And you have your 1 minus 1. You have your y minus 1 here as well. Is it? Y minus 1 factorial. How can we transform again? We might need to do another transformation. There's no y minus 1 yet. This looks like something we have done already when p is released. Oh gosh, I don't have time. N minus 1 factorial. I can have n minus 1 minus y factorial, y factorial. Is it y factorial now? Y minus 1 factorial. P to power y, 1 minus p, n minus 1 minus y. Does this give us anything? Not yet. But these other ones can. N, p, sigma, y is equal to 0, n minus 1. I'll probably need to round up the class without completing this. We'll find a way to explain it, or I just work it out and send you the proof. P to power y, 1 minus n minus 1 minus 1. So this looks like something we need already. Do you agree? So this is n minus 1 combination y. This is p to power y. This is 1 minus p raised to power n minus 1 minus y. So this is exactly the first one. So this is going to end up giving us 1. So we have an NP here. The only thing left is to complete this part. And this part will definitely be the one responsible for the square. So this, I think, will produce another P or another N. And at the end, you can now factorize NP out of it. Okay? I can't remember what the last result of this was, but we don't have the time to check now. So either I send you the proof, formal proof, or we find time on Monday we do. Because the idea is not that this will be required of you, like I said. It will never be required of you. But the idea of transformation of variable to achieve a goal, the idea is what I want you to get from this proof, not because it's necessary. So now that we have our mean and variance, more or less, it's also in our formula booklet here. With this mean and variance, the next set of questions are relating to mean and variance of probability distribution. So I think we will need the first class of Monday, or I don't even mind the whole of Monday, to finalize all this. Then continuous random variable begins on Tuesday. Okay? My apologies, please, for the lateness. Thank you.